Hello coders, I welcome you all. In this video, we are going to perform a very important task of NLP, text cleaning. This is required in all the NLP project. We will make the text ready so that it can be used by a machine learning model for prediction. Here we will perform several steps of text cleaning that you can see on the screen. First, we will load our book review dataset. Then we will perform lowercasing of the text. After that, we remove extra spaces. Then we will perform tokenization. After that, we will remove stop word. Also, we will perform lemmatization. After this, we will use count vectorizer and TF-IDF vectorizer to generate the features from the unstructured text. And in the final step, we will visualize and compare the count vectorizer and TF-IDF vectorizer matrix. We will make the text ready so that it can be used by a machine learning model for prediction. Right here, we will perform several steps of text cleaning. And at the end, we will create a complete function. This function can be applied directly to any unclean text. And in the future, when you work on more text data, you can make it even robust. So we are going to work with pandas, Spacy, count vectorizer, and TF-IDF vectorizer. By the end, we will also find the top important words identified by count vectorizer and TF-IDF vectorizer, and then compare the results. Watch this video up to the end. I am sure you will learn something. So let's get started. You can see currently we are using Jupyter Notebook, and this is our step 1. Import pandas, and we are going to load our data set. So let's import pandas first. Import pandas as PD. Let's execute this cell. Currently we are importing only pandas. We will import other libraries when they are required. So now let's load our data set. pd.read_csv, because our data set is available in .csv file format with name book_reviews_500.csv. Let's assign it to one variable data. Let's check top 5 rows of our data set. You can download this data set from my GitHub repo. Link is provided in the description of this video. Now you can see our data set contains this many columns: ID, book title, author, year, given rating, review text, and review date. But for sentiment analysis type of task, we are interested in this review text column only. So let's check this particular column, review text, because we are interested in this particular column only. So as you can see, normally pandas cuts off long text in a column and shows this ... but we want to check entire reviews. So for that, we have to set this particular option of pandas. We are interested in display and max_call width parameter of the display, and let's set it to none. When we set this particular parameter max_call width to none, it allows us to see the full review text without trimming. Let's check. Let's execute this cell, this, and this as well. Now you can see, we can see entire reviews text, and this also helps us clearly view the complete text before and after cleaning, right? So now just we have completed our first step, import pandas, and also we have loaded our data set. Now let's move to our second step. Now in the second step, step 2, lower casing. So right now we see mixed casing that you can see. Both uppercase and lowercase reviews are available inside our review text column. So let's convert it into lowercase. Otherwise, loud in uppercase and love in lowercase will be considered as two different words that we don't want. But the question is, why lowercase? Can't we use uppercase? Yes, you can use uppercase as well. But professionally, we always convert text into lowercase only while working with text pre-processing task with NLP. So now let's use this particular column, review text. Let's copy this particular column name. Let's paste it over here. Let's execute this cell. And we are going to use string of pandas and lower method of pandas. Let's execute this cell. Done. Let's create new column with name clean underscore text with this lowercase reviews. Let's execute this cell. Done. Let's check our data set. You can see now we have saved the output in a new column with the name clean text that you can see. Now you can compare review text and clean text. Now reviews are in lower case. Done. So now just we have completed our two steps. Import pandas, and also we have loaded our data set. Also we have completed lower casing. Now all our reviews are in lower case. Now let's move to our next step, our third step. So now our step number 3. Here we are going to remove symbols and punctuations. So first let's print our clean text column that just we have created. So now in the reviews we are mainly interested in words so that we can identify whether a review is positive or negative. That means we are interested in the text only, not symbols or any other things. So now we are going to remove everything except letters and spaces. So for that, again, let's use this particular column, clean underscore text. Again, we are going to use string, and this time replace method. So string, and here I'm using one regular expression A to Z lowercase, S for space, and empty string. And here we have to set regex to true so that pandas will consider this as a regular expression. That's why here we are making it true. Regex is equal to true. Let's execute this cell. So here this particular regular expression caret A to Z, which is in lowercase, and space means anything that is not a lowercase letter or a space. So numbers, punctuation, emojis and symbols are all removed and replaced with none. After this step, only alphabets and spaces remain in the reviews. Just to compare, let's assign it back to modify our existing column. Clean text is equal to this particular statement. Let's execute this cell. Let's check. Now you can see here numbers, punctuation, emojis and symbols all removed and replaced with none. We have only alphabets and spaces remain in the reviews. Now you can see our column clean underscore text contains only text, nothing else, right? So now we have completed our 3 steps. We have imported pandas. Also we have loaded our dataset, book reviews dataset. Also we have performed lower casing that you can see, and also we have removed symbols and punctuations. Now we have only clean text that you can see. So now our step number 4. Here we are going to remove extra spaces. So before we start, let's display our clean text. So as you know, we just removed numbers, punctuation, emojis, symbols, etc. from our text. So it may introduce extra spaces that you can see here. So better to remove such extra spaces that we are going to perform in this particular step. Remove extra spaces. So again, we have to use this particular column, our clean text column, again string, again replace method, row string, \s for space, plus and single space. Again, don't forget to make regex to true. So this will be considered as regular expression by pandas. Also string and string. So here \s plus means one or more white space characters. So multiple spaces are collapsed into a single space. And also we are using string dot strip. Here we also remove spaces at the beginning and end of the text. Let's execute this cell. Done. You can see to compare, let's modify our existing column. Let's check. I think done. We have successfully removed extra spaces. Now let's move to our next step. Step 5. where we are going to create a function. So before we move forward and use Spacy for text preprocessing, let's create a function so that in the future we can apply this function directly to our unclean text, any other data set, right? So def text underscore cleaning, and here we are passing text dot str dot lower, and let's assign it to one variable output. Right now on this output we have to use, just we have completed this, and now we have to use this replace. Again let's assign back to output. Again on this output we have to use this, which removes extra spaces. Done. So after lowercasing, this out will become input to this. After removing extra symbols, again we are assigning it to out, and this will become input to this. Again out, and let's return out. Done. Let's execute this cell. So now our function is saved with this particular name, text underscore cleaning. This function we can apply directly to any unclean text that will perform this many tasks. Let me show you how. So again, let's load our data set, data.head. You can see our data set, right? Before any text preprocessing. Now I want to apply this function on this unclean text, review text. For that, first we have to call this particular function, and we have to pass this column, unclean column. Let's copy this, let's paste it over here, and let's create one new column, clean underscore text. Let's execute this cell. Done. Let's check. You can see here our clean text. So on this particular review text, which is unclean, we applied lowercasing. Also we have removed all the symbols. Also we have removed extra spaces by just one go, that you can see. Hope all of you are clear with this, right? So we have completed our step number 5, create a function for text cleaning. Now let's move on. As you know, just we have completed our step number 5, and we have created this particular function, text underscore cleaning. Just to check whether this particular function is working or not, we have performed this. So let's make it comment, and here as well. Done. Also we have to comment this and this as well. Let's execute this cell and this as well, right? So now just we have commented extra statements. Now let's move to kernel and restart kernel and run up to selected cell. Let's click over here. Yes, we want to restart. So here we are executing each and every cells one more time. I think done. And we have our clean underscore text, right? Now let's move to our step number 6, Spacy pre-processing. So now let's create more number of cells. Done. So now that, as you can see, we have our clean text. The next step is text pre-processing, and for that we are going to use Spacy library. So we will focus on 3 main steps: tokenization, lemmatization, and removing stoppers. So first, for that we have to import Spacy. Let's execute this cell. Done. Now after that we have to load Spacy pre-trained model, English, core, web, and SM for small size. So here we are loading small size pre-trained English model of Spacy, and let's assign it to one variable. Let's execute this cell. If you are facing some error here, you have to download this particular model from Spacy. You have to go Spacy website, and their proper instructions are listed how to install this particular model, pre-trained model of Spacy, right? I will put all this command in the description of this video, right? So now we have imported Spacy, and also just we have loaded Spacy small size pre-trained English model. Now let's move on. So here we are creating another step. Step 7, try pre-processing on one review only. After that, we will apply the same method to all the reviews. So now let's take just one review from our clean text. Let's take first review and let's assign it to one variable, DES. You can use any other variable as well. Done. So this is our first review. Now let's pre-process this review using Spacy small size English model that just we have loaded over here. So for that, we have to use this particular object and we have to pass this review that we have stored inside DES, and let's create one variable doc. Let's execute this cell. Done. So after this step, entire pipeline has been applied on this particular review. Now let's perform tokenization. So for that, I'm going to use list comprehension. So doc for token, we are looking inside doc, this one, and print token. So first doc, we are looking token inside doc and we are printing token. Let's execute this cell. You can see tokens, right? So please remember, normally if we split text, we just break it whenever we see a space. But Spacy's tokenizer is much smarter than that. For example, if you have USA, if we are using simple split, we would break it into U, S, A, right? But Spacy understands this is an abbreviation and keeps it as one token, right? That we have applied over here. Now let's remove proppers. So here, if not token dot is underscore stop, you can see if not token dot is underscore stop, then only print the token. So is underscore stop will check for each and every stop words available inside Spacy dictionary and it will be removed. Let's execute this cell. Done. So now next step is lemmatization. Lemmatization reduce each word to its base form called lemma. So was becomes be and playing become play, right? So we are going to reduce each word to its base form, also called as root form. Here we called it as lemma. So again, I'm using same list comprehension. Just we have to write dot lemma underscore. That's all. Done. You can see. So now here we have performed 3 steps: tokenization, stop word removal, and lemmatization, that you can see. And our text after lemmatization, all the words in this particular review in their base form. But here we have to join them back into a string, right? Because you can see it is inside list, but we want to make it review back like this, right, in string format. For that, we have to write like this, space join, and we have to pass this list comprehension here. Let's execute this cell. Done. You can see our review is back in a string format. So now you can see we have performed pre-processing using Spacy on one review. Now we have to apply this to our entire column, to entire this particular column, clean underscore text column, that we are going to do next. So now again, let's create more cells and we are going to consider this as our step 8. And here we are going to create a Spacy function for text pre-processing. So let's create one function with name token underscore top word underscore lemma. And here we are passing text. Again, let's copy this and paste it over here. Here we are applying entire NLP pipeline on text on our reviews, and also this. Let's copy and paste it over here, and we have to return this. Done. Let's execute this cell. So now our function has been saved. Let's apply this function to our clean text column, this column, and we have to use dot apply, and just we have to provide this function name only without parentheses. Let's execute this cell. Done. Let's modify our existing column. Let's execute this cell. Let's check. You can see loud become love. Let's use sample to fetch random cells. You can see missing converted to its root form this. Now we can say our function is working properly, right? Now we have successfully completed our step number 8. We have created a Spacy function that will perform tokenization, stop word removal, and lemmatization, right? Let's move on. So now let's move to our step number 9, where we are going to apply count vectorizer. So now our text is clean and pre-processed. that you can see. The next step is to convert this text into numbers, because machine learning models only work with numbers, not words. So for that, first we are going to use count vectorizer. Count vectorizer simply counts how many times each word appears in the dataset, but still it works well on many NLP related tasks. First, we have to import from sklearn.feature_extraction.text. We have to import count vectorizer. Let's create one object of count vectorizer as CV. Now we have to perform fit_transform on our clean text column. Let's assign it one variable, DTM, document term matrix, because at the end count vectorizer will generate document term matrix. Let's execute this cell. Let's check. You can see it is sparse matrix because we have many zeros, right? So this is the compressed sparse row format automatically created by sklearn. Check this. We have to convert it into array and let's assign it to df. Let's execute this cell. Let's check. Now also we want to check features. So for that we have to use get_feature_names_out. You can see from our text these many features are extracted, right? Visualize it properly. Let's create pandas data frame with this df and columns equal to this. Let's copy, paste it over here. Done. Let's execute this cell. You can see here our document term matrix. Here all the documents, 500 rows and term, that you can see. That's why it is called document term matrix, document and terms. Let's assign to df1 is equal to this statement. Let's comment this and let's check one more time. You can see total we have 500 rows and 375 columns. We can still reduce it, right? So let's write stop words equal to English. We have already removed stop words using Spacy, but one more time we are removing stop words using count vectorizer. It is not duplicate step. Please remember this, right? Because both Spacy and count vectorizer of sklearn have the different stop word list. So because of that, sklearn may remove a few more stop words. Let's check. You can see total we have this many columns. Let's put it over here. Now let's execute this cell, this, and this as well. You can see after that we have this many columns. 3 more stop words are removed. As I said, both are maintaining separate lists for stop words. Still, we can remove more features. So for that, we have to write min_df minimum document frequency is equal to 0.1. You can set to any. So please remember, any terms that appears in less than 10% of the reviews will not be displayed here. Let's check. Let's execute this cell, this, and this. Now you can see we have just 15 columns, means 15 features. That's good, right? So this way also we can filter out the features which are not important so that we can keep only relevant features. That will also reduce the chance of overfitting and our training become faster, right? After this, we can see some important words only. So before we move forward, let's display top most frequent words which identified by count vectorizer. Here df1.sum. You can see dot short underscore values. Now it is in ascending order and tail 10. You can see from bottom to top. These are top most frequent words identified by our count vectorizer. You can see, right? Now we have successfully applied count vectorizer. Now let's move to our step number 10, where we are going to apply TF-IDF vectorizer, term frequency inverse document frequency vectorizer. Now our step number 10, where we are going to create TF-IDF matrix. Let's create more cells. This is exactly same. like count vectorizer. Let's copy, let's paste it over here, and also let me copy remaining code and this as well. So here in place of count vectorizer, we have to use TF IDF vectorizer, and here also TF IDF vectorizer, and we are keeping this as it is, TV. Here also TV, DF1 and DF2. Here DF1, I think all done. Let's execute this cell. Let's check. Yes, it's done. Again 15 columns because we have removed stoppers and also we have used minimum document frequency 0.1. Any term that appears in less than 10% of the reviews will not be displayed here. Same we are using in TF IDF vectorizer as well, that we have used here in count vectorizer. Now again, let's copy this, and also we are going to print top important words identified by TF IDF, term frequency inverse document frequency. So please remember, TF IDF reduces the weight of very frequent words and increase the weight of unique important words. Let's check DF2. You can see these are the important words identified by TF IDF vectorizer. So before we move forward, let's plot this top 10 words identified by count vectorizer. So here top 10 CV is equal to this statement. Let's copy, let's check. So these are top 10 words identified by count vectorizer. So we have to use this variable and dot plot. By default, it is showing line plot, but we are interested in bar plot. You can see, and let's convert it into horizontal bar plot so it looks better, right? You can see this is the most frequent words as per count vectorizer and remaining words that you can see. Same, let's copy this and let's plot top 10 words identified by TF IDF, this one. But here top 10 TV is equal to this statement. So let's use TV. Let's execute this cell and this as well. You can see top 10 words identified by TF IDF vectorizer and top 10 words identified by count vectorizer. Let's put this plot side by side so we can compare it, right? So here is the code that will plot top 10 words identified by count vectorizer and by TF IDF vectorizer side by side. Just we have to change variable names, top 10 underscore CV and top 10 underscore TV. You can see top 10 underscore TV of TF IDF and top 10 underscore CV of count vectorizer. Let's execute this cell. Great. Now we can see this plot side by side. I think we have to remove some of the words. Then only we can compare this plot properly. So we are going to remove book, review, and this http by book.com. For that, here we have to add inside stoppers list, review, and this. Let's execute the cell, this, done. Let's copy this stoppers list. Let's paste it over here inside TF IDF vectorizer. Let's execute this cell, this, and all the cells. Now done. Now it's look better. Now we can compare this easily. You can see love is upside as compared to count vectorizer because it is very important, right? Same pad is also upper side, which is important for review text classification, right? So here is lower side, here is upper side. Here is also amazing at upper side in TF IDF vectorizer as compared to count vectorizer, right? This way we can convert our text into numerical format using count vectorizer and TF IDF vectorizer. And this is depend on the problem on hand. I hope all of you are clear with text pre-processing. Now our text is in numerical format that we can feed into machine learning models. Now you can see our both functions are ready. This is our first function. Let's copy this. Let's paste it over here. Also, let's take our second function, this one. Let's copy. Let's move down and let's paste it over here. So here we are going to combine these two functions into one. So we called it as a module so that we can use the same text pre-processing steps in our upcoming NLP projects. Also, you can save this to .py file, .python file. So when you required, you can import this module for text pre-processing. I am assuming that we will create .py file. So we are going to import each and everything, pandas and Spacy as well. And also we are going to load Spacy small size English model, EN, core, web and SM. Done. And here our two functions. Our first function for basic text cleaning, convert to lowercase, remove everything except letters and spaces, and collapse multiple spaces into one. And this is our second function. Here we are performing tokenization, removing stop words and performing lemmatization. Right? Now let's combine these two. You can give any other name. I'm giving cleaning and pre-processing. And let's pass text over here. So let's call our first function, text cleaning. And we are passing text. So from here we are calling this particular function. And let's store output into this particular output variable. Now let's use this output dot apply. And here we are going to apply this function. So here we are storing output of this into output, and here we are using same output. On that output, we are calling this particular function and return output, our final output. I think our file is ready. Let's execute this cell. Done. So now we have successfully stored our functions. Now let's check this. So let's copy this, our data set. Let's paste it over here. Let's check. You can see unclean text, our review text. So now we have to call this function that will internally call our two functions, this and this one, right? Data, and we want to clean this review text. Let's copy, paste it over here, and we have to pass it to our function, this function. Let's copy this, let's paste it over here, and we are calling this function with review text. And let's create new column with name clean underscore text is equal to this statement. So here we are creating new column with this name clean text here. Let's execute this cell. So this will call our function, this function, and internally this function will call these two functions one by one, right? Done. Let's check, and you can see here our final clean text. So this way you can apply our final code on any text. I hope all of you are clear with this, right? How to perform text pre-processing. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.